Hi, everyone, and welcome to AEC-tech Talks, New Design Technology in Practice. I'm Niknas, and I would like to welcome you here today for our first online webinar of this year. AEC-tech is an online platform and community designed to keep you updated on all the latest innovations and trends happening in the building industry. This event will be recorded and can be found on the AEC-tech YouTube channel. If you have any questions or comments during the session, please feel free to post them in the chat box for the Q&A section. Today's event will run for 60 minutes. So as we all know, in recent years, technology and innovation has revolutionized the way we live and work in many ways. And now the rapid development of tech is challenging designers and builders to continuously navigate which tools would best serve their projects and teams. Today, we ask industry-leading designers and managers on what tools they've been using and how they effectively are integrating them into their workflows. First, we will have short presentations from our three guest speakers, wonderful guest speakers who have graciously accepted our invite. Thank you so much for being here. And we will follow this with some questions from the audience. I'm going to briefly introduce our panelists and we'll let them introduce themselves and their work with more details themselves. Michael is a senior computational designer with Buro Happold, where he helps a variety of teams solve complex problems through planning and executing computational workflows. Michael has recently led initiatives throughout the US and UK offices in developing digital tools for evaluating embodied carbon within the company's open source coding platform called the Building and Habitats Object Model, BHOM, which won the 2020 AIA Technology in Architectural Practice Innovation Award. Michael is the lead of Henning Larsen's computational design team and is responsible for digital workflows and has been involved in the development of several simulation programs used for early stage development and thereby combining architecture and engineering from the very beginning of each project. Alireza is an architectural designer in Stantec, Boston, with almost 10 years of experience in computational design, developing tools for architects. Thank you so much again. With this, I'm going to hand it to Michael, and we look forward to all your presentations.
Thank you so much. I'm going to go ahead and share my screen so we can have our presentation. Is that visible?
Yes.
Great. I'll move the chat out of the way. Great. Thank you so much for having me. As a member of Buro Happold, we have a lot of different offices all over the world, and we represent quite a large body of work: architecture, engineering, sustainability. So it's really an honor to share what we've done with with you all today. So I'll be going over a little bit behind the scenes of what's happening within our computational teams at Buro Happold, and specifically what you see right now, the BHO, the Buildings and Habitats Object Model, sustainable code at scale. So I'll be going into what the BOM is. We say BOM for short, so you don't have to say the whole name, but the philosophy behind it, why we've developed it, what problems we're trying to solve, the structure of the BOM, its object-oriented and flow-based programming applications, and then we'll see some demos and example applications. So as I mentioned, Buro Happold is involved in many, many things as a multidisciplinary engineering firm. We work with architects all over the world on challenges that are growing in immense proportion. So every year we see more and more complexity within the projects that we're associated with. And when I say complexity, there's essentially three different types of complexity that we're noticing as a firm. We're noticing more and more that our models are increasing in complexity. Now we're not only having models that have a structural schema, or fully laid out structures throughout a building, a tower, a stadium, a school, a hospital, but you're also pairing all of this richness in the structural schema with things like your envelopes, your facade system, any kind of CFD analysis or people flow or architectural programming. And additionally, all of this is always in flux until the building is built, essentially. So how is it that we can start to bring in all of these complex models and systems in the same space? And in addition to the models becoming complex, our process is also growing in complexity. So for each problem that we're faced, with each question that our clients ask us, we need to be able to come up with a clever solution, or solution that works with their designs, with their priorities. So we need to kind of quickly move from digital modeling spaces, whatever those may be, Rhino, SketchUp, Revit, all of these things, into some things that let us manipulate those model elements, the building information modeling elements that we are designing and building, whether that's in code or in visual scripting, in images, videos, documents. All of this process is increasing in complexity. And lastly, what I'll touch on is problem complexity. So we have the models, we have the workflows, but we're also asking better questions, just in general, as humanity is beginning to understand kind of the consequences of our actions environmentally. We're trying to understand how we can kind of counteract and kind of tip the scales back with respect to our carbon footprint. And additional problems that are kind of growing in scale and urgency can't necessarily be solved with a single solution. So we wanted to kind of recognize that out the gate, that we're dealing with lots and lots of things. So our company around 2015, late 2015, developed an open source platform called the BOM. And the BOM is essentially made to do a couple of things. The idea behind it was to be able to connect everything to everything. So at its core, its fundamental job is to be an interoperability software, connect everything to everything, everyone to everything, and everyone to everyone. In this way, we think that we've transformed the way that we structure code so that we can better reflect the way that we naturally work and think. How do we do this? We do this through the use of three distinct elements within the building and habitats object model. There are what's called adapters, so things that link to and from other pieces of software. So Revit to Rhino, for example, is a very popular one within our industry. People model really complex geometry. How do you then enable that geometry to become more intelligent about itself, whether it knows its weight, density, its mass, or its embodied carbon footprint, or its impact on a much broader scale as it relates to human behavior? Additionally, with adapters linking things together, what we've done is also enabled this kind of action, or this passing between software, through the use of a curated data set of objects. So we're making an open source platform for people to come together and communicate about the objects that they use in their day to day. So as a structural engineer, for example, would always use um, a beam of a specific size or length. We can then kind of cross communicate across our disciplines. So if I'm a mechanical engineer, I need to know about the beams. I need to know about the structural placement. As an architect, I care about all of these things coming together and how it impacts the space and the experience. And then in order to kind of enable the flexibility of parametric workflows, we've developed an engine. These are just a series of customizable tools that operate on all of that curated data, all of the objects, and within all of the platforms. And wrapping all of this together is what's called a BOM toolkit. So the BOM, you can kind of imagine, is just a giant library of different pieces of functionality or toolkits. And I'll kind of go through a few of them in some of the examples today. But I'll just flash kind of on the screen some of our public facing toolkits, and then some of our kind of behind the scenes, not quite open source, but some of the things that we are working on that will be brought to the public eye eventually. But some important things like our machine learning toolkit, our lifecycle assessment toolkit, Rhino, Revit, um, Speckleworks, Dynamo, all of these things are being developed by people who are interested in these spaces and want to be able to kind of talk back and forth. So to give you a quick visual, this is kind of a standard workflow, right? When we're trying to go from Rhino to Revit, we need to pass it through some sort of like rationalizer. We need to save as or export, and then we need to push some data into Excel that we wanted to extract from that and go back and forth. That creates a lot of redundancy. What the BOM is doing is effectively just eliminating all of the redundancy and allowing a very seamless communication between these softwares. So again, another diagram that kind of eliminating all of that back and forth redundancy. You can now go directly from one thing to another thing without having to kind of convert save as. Um, Okay, so I'm going to kind of breeze past a lot of the structure. It gets quite technical, but I'll also share with you a link to this presentation. So if you are curious, you can go back through and look through it. But just to give you kind of an eye into the code behind the scenes, it's a very simply written, it's very simple to read set of objects in the object model. So an object is just defined by a list of its core properties. So a circle, for example, we are just basically providing a framework for everyone to be able to define and create their own objects that are automatically interoperable. Um, so we'll kind of go through here. This is what a bar would look like, right? With its core properties. It's a little more complex because you can start to embed information about the forces, the constraints, the nodes, the orientation, all of that. But once it's formatted, it's done, and everyone is on the same page about what that object is and what it can do. And then let's see. So then using the object model, we'll kind of click through here. You'll see a lot of different UIs, and that's on purpose because the BOM is a tool that is capable of being used in all of these different UIs. So in Grasshopper, for example, a single download gets you the access into this open source tool. You can create different objects. You can kind of see this huge list of different objects that are accessible. You can kind of imagine these are just instances of BIM elements, right? The more information you put into these things, the smarter and smarter they become, the more useful they are in different workflows. Um, you can also create custom objects, things that aren't necessarily defined if you want to prototype, and work those prototype objects into your visual scripting or your code. You can quickly go from a prototype to a fully fledged piece of code very quickly. Uh, and since this is all about data, what we can do at any time is set the property of any kind of element, or we can get a specific property. It's essentially just looking at all of these elements agnostically and just saying like everything is just data at the end of the day. And what we're doing is kind of providing a bit of organization around that. The engine. The engine is important because it allows us to then work with all of these different objects and modify them, ask questions about these objects. We can run calculations on them, and all of this in line with being interoperable, right? So we can send some data to a finite element analysis software, ask it questions, run that simulation, pull it back, all in the same time. BHOM loves flow-based programming, but it also loves things like Excel as well. So again, a single install gets you access to all of the components and tools. Rhino or Grasshopper, Dynamo, and Excel. Kind of take a quick look at the UI. I'm mindful. I'm trying to keep the presentation a little bit shorter, so we'll probably cut some examples out, but I want to be able to show you just a couple of examples before I tidy up here. So just quickly scroll through this video. I have a fully built out structural model in Revit on the left-hand side. Using the BHOM, I can pull all of that information across into Rhino, which is what you see in the middle. And it's represented in this kind of pink abstract look. That's because we're enabling very quick passing of information, and we're just kind of using the lightest weight visual representation possible to do that as quickly as possible. And then what I want to show here is that you can really just make any kind of script or workflow that you're normally used to in your own firm or practice. You can operate on these objects just like normal. You can use things like other toolkits in the BHOM, like the Lifecycle Assessment Toolkit, to then calculate embodied carbon off of these objects. You can push that data back into Revit if you'd like by setting custom parameters. You can push it into a database if you're trying to track these things throughout your company over time. But then you can also integrate directly into other parametric workflows and tools like Human UI, for example. Is a very popular open source platform for just creating very quick dashboards. So here I've just pulled some elements, assessed them based on the information that comes with it in Revit, created a dashboard, and I was able to present that back to a client. And this is a process that's been used throughout our company on many, many projects and with others outside of the company as well. And I think the last example that I'll show here, let's see if because I want to be mindful of time, is we can also then push and pull this information in lots of different ways, right? So here we have 4 different programs, just all kind of acting in sync with one another, right? So I can program my structural analysis model. I can tell it where I want to push, where I want to pull. I can set up kind of my own custom pipeline for my workflow. So I can run a full-fledged structural analysis on anything in Rhino and Grasshopper, push that into Revit, Robot, all at the same time, and start really pushing my workflows forward. We design all of this with the understanding that we need to be collaborating, because not everyone knows exactly what Robot is for or how to interpret those results. But that's why we made it, is so that we can communicate over GitHub in an open source platform and ask questions to one another. And then the last thing I'll show here is to be able to kind of push and pull very complex geometry, study clashes, or make some visual representation of whatever it is that you're trying to show. You can literally pull and push just about anything into or out of Revit, right? So we can kind of quickly visualize things in any kind of like graphical engine that we're wanting to explore. So we can push and pull structures, mechanical systems, study the spaces, all while retaining all of the richness of our building information model. So that's my time. I have a lot more stuff here that we could talk about, but I just want to leave you with one last slide here. It's very simple. It's where you can get in touch with us. We communicate in GitHub. We have a very active ecosystem of developers and those that apply the tools. And we look forward to working with you in the future and helping you experiment with these. But that's it for me. Thank you very much.
Thank you so much, Michael. I love the presentation. BHOM is incredible. I love those diagrams. That simply shows how it's feeding into the whole ecosystem and how it's connecting all these tools. So I have a couple of questions. I'm sure our audience have questions, but we'll keep it for the end. So we're gonna move on to Mikkel and then to others.
Yeah, perfect. Thank you for the presentation, Michael. Super nice to see. And I can say that BHOM is also something that we're seeing going across different companies as well, whether that might be in in Rambøll that we're also a part of, or whether that might be in Henning Larsen. All right, let me just see here. It shared the wrong part of it. There we go. All right. So thank you very much for having me. Today I'm going to show a little bit about what I'm doing at Henning Larsen, which for those of you who don't know is an architectural company where we use engineering quite early in the processes to try to inform the way we design. So just by starting out, I wanted to share this image with you, and it was something that I snapped 2 years ago while we were attending something called AI Monday here in Copenhagen, where I am. The guy you see here is the head of data science and artificial intelligence as Maersk, which is this global transportation company in the world. And he was telling about how frustrating it was that his line of business were so behind when it came to AI and to the whole digitalization. And while he was up there and telling about all his frustrations and where he was seeing everything going, I couldn't help laugh a little bit to myself, sitting there from the construction industry and looking where we were down in the very, very bottom of his graph. But hopefully that's gonna change in a few years. At least that's what I'm hoping. But what I want to show here today is I have two cases. Not only do I want to show kind of the tools we have, but I also want to show how we're actually using them. One of the things we've started to use quite a lot the last couple of years is generative design. And for those of you who don't know what generative design is, it's where you make the computer explore different design options. So basically you set up a few parameters and then the computer will go through and generate volumes from that. Now where generative design becomes really strong is when you combine that with what we call augmented design, where you have live analysis that is running on the side. That means that not only can the computer actually generate different forms, it can also evaluate on them immediately. That means that it can both figure out which way should it be going. Should it be making things better, or should it go in a different direction to optimize some other stuff? So we've used this at a lot of different skills, and this is just some of them. We've had everything from very large master plans to all the way down to facade optimization. The very big difference between some of these are, for example, in our master plans, we're never really trying to optimize on a certain thing, because there's so many different parameters, so many different values. It can be extremely hard to say this is the only single solution for this problem. So in this case, we are using generative design to explore different ways of creating cities and to try to open up our minds to what kind of options could we go for. In the other instance where we have the Boston Seaport, it's a very, very defined narrative. We have two things. We have irradiation on facades and we have daylight. Those two things contradict each other. We don't want to have too much irradiation going into the building, while we still want to have enough daylight in there. So for that one, it's a simple kind of analysis for the computer to figure out that one case where it balances these two things perfectly. So I just wanted to define that, that there's, when we're talking about generative design, it's not necessarily just one thing or another. It can be used in many different ways. But I took one case with me here today, is Bellevue down here in the left corner. And when we got this case in, it was the developers that reached out to us. So basically they were about to buy this site and there was already a project on it. However, they kind of lacked some narrative on it. They didn't really think it had some character to it. And the tenants they were looking for were some of the big tech giants. So that means that it had to be super cool, and it actually had to perform. It shouldn't just be a standard building. It should actually be able to do an impact of the area. The problem was that the local architects, they came up with this solution, and they basically said, this local regulations here, they are so hardcore It is almost impossible to build it in a different style, at least when you want this many square meters. And we tried it out, we got the case, we followed all the guidelines, and we ended up with exactly the same results. We got exactly the same case as the local architect did. So we sat down and was like, this cannot be right. There must be a different way to do it. So what we did was we actually set up all these parameters in the computer and made it explore it by itself. So what we're seeing here is a very early stage of this. So in here, we've put up all the local regulations for it. So all these volumes that comes out are all within all the rules. Now you might then say, okay, but this doesn't really look like buildings. No, but that's actually the point here, because what this is it's just exploring the volumes and it's trying to optimize them within this set of rules. So it doesn't have to look like a building. That's not the priority. This is to show what is actually possible within the site. And what's very nice here is that this can be done manually. We can move around. We can explore a lot of different options. We can say, what happens if we place a building here or there? What happens if we place 3 buildings? What happens if we place 5 buildings? Can everything be there? And how will the buildings then look like? And when we showed this to the developer, he actually ended up being extremely happy and canceling several of his meetings. And he said to me, Mikkel, I need you to stay for another hour. I need to go through this. I need to play with this to really understand this site and to understand what is the possibilities for this one. And that's one of the first times I've actually had this kind of client engagement where they're really like, I want to sit and design with you. And I really want to understand what happens if we do this, what happens if we do that. And normally when these things comes, they'll come up with a few comments, and then we'll come back within a few weeks, and say, this was not possible. Or, if you do that, then it will look like this. In this instant, we could show it real time, how will it impact it? And what I'm not showing in here is that on the side is also running, it's running both if it can optimize more on square meters, it's running a sunlight analysis and a lot of other stuff as well. So one thing is to, of course, go through this manually, but we might as well set the computer try to explore a lot of different options. So that's what I did. We ended up running around 5,000 different cases. It wasn't really necessary. We had more than enough already with 1,000, but unfortunately I was sick right after, so the computer ran a day more. But basically we ended up with 5,000 different iterations. And then the architects came to me and asked, that's great, but what are we going to use that for? Well, we ended up setting it up to this database where basically they can search both for parameters and they can search for results. That means that when they're asking, what will happen if we go for 5 towers and we'll prioritize sun strips and maybe the overall square meters? Well, if you plug that in, then it will show you those results that fits within the requirements that you're looking at. That means that you don't necessarily have to prioritize anything before you actually set up this whole system. You can actually get in and really get a feel for how does the different properties and parameters impact this project. So what the architects did was they sorted through a lot of these different parameters and they picked up the one they liked the best. Then they started sketching from them, because even though we could put quite a lot of different things into the parameters, the computer doesn't know everything. So it still needs this architectural touch, and it needs the architect's intuition for a lot of different stuff. So they started sketching from this one, and they ended up with quite a lot of different varieties from them. Some of them super abstract and something that we haven't seen before, and some of them a little bit more to what we're used to build. So what it ended up with was something like this, where you can clearly see where it came from, that it came from the generative design from the beginning, but it doesn't necessarily look like it in the end. But it's something that really helped us to figure out how can we actually optimize this site. So that means, what do we actually use this for? Well, one thing was to, of course, inspire the clients. That's always nice, to see the fire in their eyes when they're seeing these things. Also to adjust assumptions, so they're not just saying, yeah, you need to build 6 buildings, and we need to have all the square meters and still be within the requirements. Here they could see it immediately, what was possible and what was not possible. And at the same time, they could also see what would the different decisions actually impact on microclimate and on views and a lot of different stuff. All right. Then I'll very quickly go through this. I cannot see any time here. Go a little bit over.
We are still good, Mikael. Yeah.
Okay, great.
Yes.
Then I brought the last thing here with me, and it's the thing I'm working on called the Augmented Architect. And there's no better way to describe it than having this picture from Iron Man, where he's flying around in his suit and is getting all the information he needs when he needs it. So there's no a lot of information, that's just garbage to him, because that's not necessary for him now. It will always pop up, hey, you should know this, or hey, by the way, you should go over here. Or he can just ask, how do I do this? And it will pop up to him. So what about if we did this for architects as well? Architects, they actually came as craftsmen back in the day. They were this person on the building plot that knew all the different varieties of craftsmanship. So he was both a carpenter, he was a mason, and a lot of different professions. And basically, he always knew, how to use these different tools, and he would get kind of feedback. Is this stone soft? Is it hard? How can this actually, be shaped? So what if we could use our digital tools to give kind of that feedback again? Because right now we're just sitting at our computers, and sometimes it's very, very hard to feel the connections with whatever we're doing. That's combined with, taking a lot of information, like standard information from Neufeld. If you don't know, that's kind of the architect's Bible. This is where you'll find all the standard values for how large should different things be, how should they be placed, and so on. Combine that with a lot of different types of analysis, that can really show how will your project be. And then put it into the program that the architects are actually using to design, where they have their design freedom. Well, we've done that at Henning Larsen. And there's a video here that's showing one of the very early stages of this one. So for example, here we're having a sunlight hours. And this is just running live on the site while they're building. And I know in the video, they are just deleting a few things, and it's a bit commercial video. But this actually works live while they're sitting there in Sketch. And it goes extremely fast. And when then they're ready to figure out, okay, how does it look like in the winter period? How does it look like in a specific hour of the year? It's just a button away. So even the non-tech savvy people at our office, they are able to use this. We also have, so it can implement KPIs, for example. So you can always see, are you on the right path for all your different sustainability goals? So how about your stormwater levels? How about CO2 uptake? Do you have enough trees on the site? Do you have enough greenery? All these things, will pop up when you need it. It'll be there. And when you don't need it, you can pack it away, and you can be completely free and design however you want. And for the last thing here, this is just a few of the other features that we've also implemented. So not everything has to be super fancy and give good feedback. Sometimes it's also just very nice to have an automated parking script where you just do a curve, and it will pop up with all the parking spaces that you need. Or have a quick daylight analysis, for example. So these are all the things that we're trying to get out to all our architects in the studio, and not only the tech-savvy ones. Yeah. All right. Thank you very much.
Wonderful. Thank you so much, Mikael. That was super exciting. So just a quick question. The tool that you showed us, it's an in-house tool that you have developed for Henning Larsen, right? And you've been using it. Right?
Yes, everything is in-house. Some of our tools on GitHub that is open source that you can use. And if there is anything in particular people want, then feel free to ask.
Okay, wonderful. Awesome. I have a couple of other questions, but again, I'll keep them for the end. So others up, we are gonna hear your presentation. Oh, I think you're muted, Larissa. You have to unmute.
All right, sorry.
Okay, perfect. We can hear you now. Awesome.
Yeah, you can see my screen, right?
Yep.
Okay, perfect.
Thank you.
Thanks, Nick. Thanks, Mikkel and Michael, for the great presentation. This is Ali Reza Memorian, designer in Boston office Stantec. I'm here on behalf of my team to present AMP, planning tool. And I want to start with this meme that you probably have seen it, why we are doing this. Because designers are not having fun. Half of the work we are doing is form finding, is design, is problem solving. Half of it is production and documentation, which is not fun to do. And automating these tasks can help us as designers to have more fun. So this is the reason number one why we are working on these tools. The second reason is that there are many roadblocks. There are many manual revisions in the process of design. Our tool AMP is mainly for early phases of the project, for mid to large size residential buildings, something between 20 to 5,000 units. So as I was saying, there are roadblocks like internal reviews, client reviews, feedbacks from the community, prices of materials will change. You have to go to step one. How can we streamline the process so every time you just changing few parameters, you get your design. AMP is trying to do that, is trying to streamline the process and help us to accelerate it. So that means we are saving time, we are saving money. A typical feasibility study that could have taken 3 weeks could be done in 30 minutes in a workshop that you are collaborating with the client and consultants and other people. So this slide is trying to show how that workshop, how that workflow is going to work. You're sitting with the client, they have their data, unit mix, unit areas, parking requirements, total floors and all of those good stuff. And you as a designer, you have the experience, you know all about the sustainability, the massing, the code. You bring all those things in a table. It's good to have a tool that you can see, you can monitor the data, you can see the consequences of all the actions that you make in the process of design and collaborate. So this video, this animation that you are looking at is one of the earlier prototypes of the tool, where you can see changing the unit mix, changing the sizes of the units, changing the boundary of the building, and many other inputs can change the output, the way we design the building. So this is kind of revolutionizing the way we look at designing the buildings. It is like you have a building that can be flexible, can stretch itself and fit into any given site. Mikkel did talk about generative and automated. I don't want to talk about it a lot. All I'm trying to say is that in this project with AMP, all we are trying to do, we are not trying to exactly develop 10,000 different options. We won't have only one option, make sure that is working fine. And the reason is like, this is for a quick study. It's not for one project that you want to go deep and you want to have one option really fast and analyze it. This video you're looking at is how changing the boundary of the building can affect all the data that you're seeing here. The parking, the non-count of parking to count of units ratio, the sizes of the units, and all of those things. Also getting different with a set input parameters, you can get many different design options. Also in this video, you're looking at how changing the square footages of units can influence the design. Another video is trying to show here. One feature that was really important for us in these workshops is that you can have different layouts, you can have different design. And for example, to say, I want level 1 to 4 to have this single loaded wrapping around this parking. And then after that, 5 to 8 is another typology. After that, you have this L-shaped tower. So you can plug and play and choose how you want to change your massing, how you want to change your design. And you always know that your unit mix is working, the areas that the client asked from you is working, the count of parking, all of those measurements are always working for you. And then besides the units, the layout of the building that is stretching, we are also looking at the unit themselves to also to stretch and to be flexible. We are constantly working on the idea of developing our own plan bank, and that plan bank is a library of flexible plans that you can just select and say, this is the layout I want for this building. And in those workshops, you can always toggle through different options and present them in front of the client. This is sort of like the final output of the tool. This is a report that at the end of that session, you will get a report like this, and this will enable you to start this schematic design. All of these curves, surfaces can be brought into Revit using tools like Rhino Insight to preload your Revit model with a given design. That would tremendously save a lot of time from you. And then one thing that's really important for us is that if you are not tech savvy, as Mikhail mentioned, and you are used to do these tasks all manually inside Revit, you should also be able to use the tool as the computational designer is using them. I want to end the presentation with this final video of how the workflow is inside AMP. You can bring a sketch and draw your site plan, exploring how we can bring multiple buildings and design the landscape, have the urban planning being designed. And that means we need to figure out different typologies. In this example, you're seeing a donut-shaped, an L-shaped, and an E-shaped building, and each one of them has its own challenges. Yeah, so I can end it here quickly showing how the building is being generated, how we can control, the facade, the different layouts that are stacked on top of each other, and get to the massing that you want. Thank you.
Thanks so much, Ali. That's incredible, really exciting. I really enjoyed all your presentations. So I have a question actually for all of you, and then we open it up to the floor. So how do you decide what projects, like in the office, you are applying these tools to? So is it based on the size of the project or the budget, or if the client asks you? Because what you are doing is extremely exciting and is really like reshaping the way and the workflow. So how are you familiar? How are you introducing this to everyone in the office? Because you are all from huge companies. I'm sure you work with like hundreds of people. So how do you decide what project and what group? So we can start by Michael and then go in the second.
Yeah, sure. That's an excellent question. Oh, first off, thanks, thanks everyone for your presentations. Like, really fascinating stuff. I'm like taking notes like crazy. But yeah, so we have, I guess within the last 3 years or so, we as a company internally have required that everyone, regardless of your placement within the company, should come with a standard level of understanding of computational processes within their work. And when I say like standard, that just means like you should be able to open up a computer, open up a Rhino file or a Revit file, click around and get some information so that you can talk with your client right? And then it just kind of goes up from there with, we encourage everyone to take part in our global computational collective is what it's called. It's just a global, in-house network so that people can quickly ask questions, get answers, share scripts and all sorts of things. But having that base understanding that everyone in your whole company is participating in some way in computation really empowers people to just kind of approach that on any project at any scale, any budget, because you're going to find some internal support at some level, right? So that's kind of how we do it.
Great, wonderful, thank you. So, Mikhail, how about you?
Sure. Well, it's of course depends on what kind of it is. For the Augmented Architect, it's something we're developing within the company with funding from the company, of course, because it's something that affects pretty much all the different projects. But for the rest, for example, the generative design or other of these kind of projects, it often comes up if we see that there is a project coming in where there is a kind of a problem statement. There is a new problem that we haven't tackled before, and it's something that we can see where we can use digital tools for it to kind of figure a new way out how to solve this. So it doesn't necessarily have to be that it's a huge project or it has a large budget. It's more or less, is this an interesting thing for us to try something new on? And can we learn something about it? If we can already say no to some of that, then it's not interesting. But if we can see, this can potentially be very nice for us and be a learning experience, and we might be able to reuse the same stuff for other projects in the future, then that's how we normally sort them out.
Wonderful, great, thank you, Mikhail. Alireza, how about you?
Sure. The short answer is the more computational designers we can train inside our company, the more we can use this tool. So the answer is how we can create this culture. How can we train more computational designers? And I'm glad that inside Stantec, we have this multidisciplinary office that we are constantly sharing our scripts. We are always learning from each other. So as this grows, it will eventually happen that one day that we are all using these sort of tools instead of, it's just like 20, 30 years ago, we were all drawing manually, and then we switched to CAD, then we switched to BIM. Right now, automation is the word.
Definitely. Great, thank you. So we have a number of questions. I'm not sure if you can cover all of them, but we're going to try. So Esra is asking Mikhail, where is that data? Where is your data being extracted from?
That's a good question. Data is always one of the hard things to come by, or at least clean data for that matter. It really depends on what it is. A lot of environmental data is open source. That's fairly easy to find with someone who've worked with that. If it's about more standards and these kind of things, then some of them are also on online sources, and other stuff we'll have to put in manually from some of the old books, so to speak. So it really depends quite a lot, but mostly we rely on open source stuff.
Awesome, thank you. So Sangun, apologies if I'm pronouncing your name wrong, is asking everyone, as a computational designer, what is your main task? Is it updating the tools that are used for work? And if you are involved in making new tools, what are you trying to tackle at the moment?
Yeah, I can take that one.
Great.
Yeah, Sung, good to see you, by the way, buddy. We went to school together, but yeah, I am actively making new tools. That means kind of a variety of different things. So that's in both visual scripting, where I'm prototyping things, and then I'm moving to C#, where we have most of our code bases in C#, Python, but all on GitHub, which I put a link in the LinkedIn chat at least. But so I'm moving kind of back and forth between different skill sets on project teams. So people trying to implement a simple standard workflow for placing something in a space or extracting metrics from a space. or designing forms with an architect. So that's typically done in like visual scripting environment. But when we find something that has kind of a larger impact or broader impact across our company, or across partners, we tend to go right into C#, into GitHub, because that's a very quickly scalable and it's an open way to collaborate with lots of people. So we're not necessarily, building these kind of clustered scripts that we have to kind of go back and find in this library. Eventually, 10 years from now, it doesn't work because of updates and all of that. We're just kind of, developing and deploying is also part of that.
Wonderful. Thank you. So Alireza, Mikhail, do you
Sure,
have
I can go next. So if I want to talk about my wish list, like what I want to do, I would like to see more automation, as I started my presentation, to make it more fun for the designers to spend their time what matters the most. Like if I want to give you an example, assemblies inside architectural project, how can we automate documenting those? Like how many stairs, elevators, restrooms have been designed in the years? Can't we just automate that? These are the things that we are working on. Or as many of you have a big, large library of scripts for automating in documentation. We have that also in Stantec. We are working on that. Expanding from residential to other sectors is also one other thing we are working on. Yeah, that's all I can say for now.
Great. Thanks, Alireza.
Yep, and maybe I can supply a little bit as well. In our office, we work quite a lot also with a lot of engineering disciplines and try to bring them into the early stages of design. And as computational designers, that's also our jobs to try to do that. Simply because we are often the ones that's the swift knife of the company. We know a lot of different stuff. We might not know them super well, but we know a lot, and we know how to feed it into the design process. So we often also join our teams and sit together with them and do also just basic stuff, as could be explaining how materials are impacting the projects. So that might not be as computational as digital as the computational design title might say, but I think it's important to us to have this holistic role, because that also helps us being a part of the process and understand what is it the architects need.
Yeah, definitely. Thanks a lot. So there is one more question about embodied carbon. So Golnaz is asking if any of you have managed to combine also embodied carbon analysis within your in-house tools. That's a great question.
I can also answer that. We have a team in Stantec is a big firm, I think 22,000 employees, and working with multidisciplinary offices like this is a great advantage for us. We have a team in London that is working on this topic that you mentioned, embodied carbon analysis, and we have had sessions how we can make our inputs and outputs to work together. Stay tuned for that.
Awesome. Thank you. And Michael and Mikhail sent some link. So I'm not sure if it's visible to it should be visible to everyone, right? Thanks. So Golnaz, please feel free to check those out.
I posted a link to the LCA toolkit in the LinkedIn chat, because that's the one that I just happen to have open. But
awesome.
Yeah, for us, embodied carbon, we've made substantial commitments across the industry, across disciplines, to reduce our embodied carbon impact. And the LCA toolkit is how we're documenting that, how we're calculating everything. And again, like Mikhail, we rely on a lot of open source data globally, so that we can input, kind of pair the building elements that we're modeling and we receive from our clients and feed that data back with its environmental impacts. So that's how we do it, as the LCA toolkit.
That's great, and it's all open source, right?
All open source, yep.
Wonderful. That's amazing. So there's one more question. Andrew is asking, how are you responding to regulations and trends in material use for your buildings? For example, the use of mass timber elements for the buildings presented.
Yeah, well, maybe I can start out with that one.
Sure.
Here in Denmark, we from next year will have a requirement that we're only allowed to build with, I think it's 12 tons of CO2 per square meter or something like that. I'm not too much into the regulations, I must admit. That means that there is quite a lot of focus on it at the moment. And we've been on this trend for quite a while now. And just by embedding some of the information into the softwares, that's kind of how you inform the architects to have a better feeling for how they are, how they can pick new materials and what kind of wooden members can they put in their models and what is realistic. And of course, we use our digital models to kind of get a sense if they're heading in the right direction. But what is super important when it comes to some of these cases where everything is still not documented enough for us to be 100% sure that all our digital models that just happens to be automatic is completely correct, then we'll also have in-house expert that they always go to and have everything checked. Yeah, and I think that balance is very important.
Great, thank you. Alireza, Michael, do you have any other comment?
Just for our tool, this kind of is different, but I can say we are working on a cost estimator piece to add to our tool. And so when in these meetings that we are sitting with the client, you can always also monitor the cost of the building. So that can always change.
Yeah, and I guess I can add to the question of like how we respond to different building materials. Since we have offices and projects all over the world, I mean, we have to be super agile, and that's why we try to input data from all sorts of sources and educate and provide a platform for people to kind of come together and make sure they're using the right information first and foremost. I mean, I've seen embodied carbon studies, for example, on materials that are using materials sourced from different parts of the globe, rather than using the tools or the materials that are available nearby. So helping them kind of see that there are lots of different data sets, there are lots of different sources for materials. That aspect is something we try to bring to the forefront.
Great. Thank you. And one more question for all of you. How do you see the future of this tool? So Alireza mentioned that you are training more and more people in the office. So how do you see it evolve? Do you see it as a tool that everyone in like 2 years will use in their workflow? Or do you think it will take more time or less time? Or if there's anything else that you have in your wish list?
Should I go first again?
Sure.
All right. So yeah, as you mentioned, we are trying to make that culture inside our office. But one thing that is important is that if the script is too custom, then you always need a computational designer on a project, and you don't always have that many computational designers that bring one for every project.
Yeah.
Sure, UI will help a lot. Training will help a lot, but this is a problem I guess that all of us are having right now, training more computational designers. I cannot say anything besides that.
Yeah. Thank you.
Yeah, open source is the way to go. I'm a huge proponent of create the tools, share the data, share methods that we're using across the industry. I think we could all learn a lot from one another by using the tools that we each use, regardless of if they're perfect or not. I think it's all a process. And just kind of open sourcing a couple of things and testing and trying things out. And in addition to what was just said with respect to like training and upskilling people, I mean, that's a huge problem as well. It's a huge challenge in our industry. But I think just outreach and encouragement and just being, general good citizens and stewards of the data that we have will go a really long way to making these tools last and make a real impact in the future.
Yeah, totally.
Michael, that's very hard to top up from, because
Sorry.
you're completely right. Yeah. I also think that open source is here to stay for sure. I'm pretty sure it'll be what will push our industry quite a lot forward. We've already seen it with the tools being out there. All the open source tool has been the one that's been pushing the market in the right direction. I definitely think we'll see more of that. The only wish that I have, other than what has been said, is one thing is to train more people to use it, but I hope that we'll also step a bit back and allow all the people that is non-tech savvy to also get into some of these tools and make some of them more user friendly as well, so everybody can be a part of this.
Yeah, definitely. That's definitely very crucial. So we have one more question, and with that we can wrap up. You're almost done with time. So Jeffrey is asking everyone if you are getting any pushback from builders in terms of liability.
Well, I can start out. So far, we're not seeing any pushbacks. Basically, it also comes to when are we using these tools. So a lot of the tools we're using them in the early stages. So this is where we're actually saving everybody money, and we are, figuring out all the problems very early on. So it's only a helping hand. We're not using these tools to be the final thing that comes from us. That we're definitely not ready to yet, at least not from our side. We do, of course, have automated stuff, but for everything that needs to be checked will always be checked by professionals who also have the experience to do so.
I think I can kind of piggyback on that, is because we're trying to get to that point where what we create is actually out the door. It's on documents. It's in our spec language. It's in the buildings that are being built, and it's traceable from beginning to end. And that's an extremely daunting task. And of course, I think that's where the question is coming from. There is liability in that. It's like, oh, well, your script generated this error in my building, so you're responsible. I think that's why open source, there's beauty in that as well, to kind of lean into that to answer this question, is because we have full documentation of how we arrived at a certain decision in the code. We have a conversation about it. We have implementation. We have people being trained to use it and then deploy it. So there's lots of different check-in points. And I think that's what really matters, is having those moments in time where you can say, okay, is this right? Yes, let's move forward. Is this right? Yes, let's move forward. Instead of kind of looking at it like this whole big picture, which gets extremely daunting. But there's also the aspect of collaboration that I wanted to touch on with this question. We've recently been talking with a rather large construction contractor and cost consultant, where we were wanting to engage them and get their input in cost consulting across all stages of design using the BHOM. And that's where they brought up liability as an example. It's like, we don't want to be pegged to a certain dollar amount at early stages that's then reflected at the end. So we just communicated with them, and we're like, well, what degree of freedom do you need to be able to input and add to these tools? And so they told us, and we just did that, right? And now liability is a thing of the past, and we're integrating their input much, much earlier, and we're just kind of declaring the scope, right? So
That's really smart.
If I also want to quickly answer,
Sure.
we are not changing the way we are designing traditional architecture. The tool AMP is not a new thing. It is exactly the way we are designing buildings. It's just automating it, making it faster, more accurate. So we haven't seen any pushback, and I think clients are more open to see these technologies being used in these workshops.
Awesome. Thanks a lot. We are 2 minutes over time. Thank you so much, everyone. Thanks to the audience for participating, for being here. So the video will be recorded. It will be on our YouTube channel. Please subscribe and follow us on social media. You can also sign up to our newsletter on the website. And thank you again. So we look forward to seeing you all again at maybe another event. I really absolutely, and I didn't realize really the passing of 1 hour.
thank you so much for having us.
Thank you.
Of course, thank
Thank
you.
you.
everyone.